Good afternoon, everyone. So the first program in Devops lab is Introduction to Maven and Gradle, overview of build automation tools, key differences between Maven and Gradle, installation and also setup. Before that, so in the previous video, I have shared you the introduction to DevOps. So now DevOps, you know that DevOps, it is a collection of two words, that is development and operation. It represents a culture approach that emphasizes collaboration between development and also operation teams to streamline the entire software delivery lifecycle. So DevOps is a software development approach which emphasizes on collaboration, automation, and continuous delivery to provide high quality products to the customers quickly and also efficiently. It just break down the wall between the development and the operation team to enable seamless communication, faster time to market, and improved customer satisfaction. And also, it allows a team to handle the complete application lifecycle from development to testing, operation, and deployment. It shows cooperation between the development and also operation. It groups to deploy code to production quickly in an automated and repeatable manner. So every phase of the software development lifecycle, including planning, coding, testing, deployment, and monitoring, is heavily automated in DevOps, and this improves productivity, ensures consistency, and also lowers the error rates in the development process. So this culture of continuous improvement is also promoted by DevOps. Where the feedback loops are incorporated into procedure to facilitate quicker iteration and better decision making. And also, organization can increase their agility, lower the costs, and also speed up the innovation by adopting DevOps. Okay, so there is a delivery pipeline involved in DevOps. Pipeline in terms of DevOps is basically called as different stages that software goes through before it is released to the production. So there are three stages. One is the build, another one is test and release. Build, test, release. There are three pipelines, which means three stages. In the build stage, where the software code is compiled and packed into a deployable unit, and in the testing stage, the software is rigorously tested to ensure it functions as expected and identifies any bugs. Release stage, where the software is deployed to production for end users. So the DevOps works basically on these three pipelines: building, testing, and releasing. So this DevOps will remove the wall between the development team and the operation team. In many cases, these two teams will work together for the entire application lifecycle, from development to the development to till the deployment of the operation, and develop a range of skills not limited to a single function. So the team in charge of security and quality assurance may also integrate more closely with development and operation over the course of an application's life cycle under various DevOps model. So, a DevOps engineer combines software development and also IT operation to improve how software is built and deployed. So, the main responsibility of this is building and maintaining the tools, and also collaboration with the teams and monitoring the system, improve the process, ensure security. So, there are 7 C's of DevOps. One is the continuous deployment, continuous integration, continuous testing will be there, continuous deployment, continuous monitoring, continuous feedback, and also continuous operations will be there. So these are all the basic concepts of DevOps, which I had explained in the previous video. So now let us start with program number 1. Here in this program, you should write notes on introduction to Maven and Gradle, and also you should write the overview of these two automation tools, and also differences between Maven, installation and setup procedure for Maven and Gradle, and also execution of how do you install it in the system. So basically we are operating this on the Ubuntu operating system. So overview of build tools here. Maven, it was these build tools are essential in modern software development, particularly for Java based projects. We use these two tools, Maven and Gradle, and these tools simplify and automate the task, such as compiling the code, packaging the application, running the tests, managing the dependencies. Everything will be automated without any human intervention. But in case of the without DevOps, we have human intervention for each and every phase. But here, there will be no human intervention. Everything is automated using these two tools. So Maven, it was it was originally released in 2004 by the Apache Software Foundation, actually. And Maven is well established automation tool because it focuses on the project management and understanding project structure through conventions. It uses XML configuration and follows a convention over configuration approach. It is very simple to use for standard Java projects. And also, there are various key components which are involved in Maven. So, in that, the first, the key components of Maven is this: POM files, dependencies and repositories, build life cycles, and plugins. So we know that it is a powerful project management tool, and which is purely based on POM file. POM is nothing but project object model. It is used for project building, dependency, and documentation. So whenever you install a Maven, it comes with a POM file where it gives POM file basically to store your project details, the structure of the project, and to run your project, what are the libraries and what are the dependencies your project requires. Everything will be stored in a file called as POM, which is a project object model. So and that is about POM, and it uses XML format. Okay, so we should adhere to the strict XML format because we have to follow when we are writing configuration file using XML. We should adhere to its rules and regulations very strictly. So that is about POM file, and then we have dependencies and repositories, and these are the external Java libraries which are required for the project, and repositories or the directories, okay, of a packaged jar file. It is a jar file basically. Dependencies are nothing but what are the libraries that we require to run our project. That's it. And local repository is just a directory on your machine's hardware. If the dependencies are not found in the local Maven repository, it will download them from the central Maven repository and puts them into your local build life cycle is nothing but a sequence of steps involved in Maven. Like first we should compile, and then we should, after compiling, we should run the test cases. After running the test cases, we should take that to the deployment phase. So there is a fixed sequence of steps involved when you run a project using Maven, that we call it as a build life cycle. And build plugins. Plugins basically, say for example, when I cook a cake, when I bake a cake, I require various tools, no, like knife, I require oven, I require, and other ingredients I require. To bake a cake, whatever the ingredients or whatever the other tools I require, that we call it as a plugins. Okay, so basically to bake a cake, we require so many other tools. So in terms of DevOps also, plugins are nothing but there are so many plugins: build plugin, compile plugin, uh, and default plugin. So many we have. Build plugin is nothing but a compiling a code. When you create a code, that should be compiled. It is also called as a plugin in terms of Maven. Okay, when you test a project, that testing of the project is called as a plugin. That's it. So plugin is basically a reusable functionality. That's it. So yeah, so here we have the complete life cycle of maven. Validate is nothing but validating the configuration, project configuration, compiling the source code into the bytecode. Test is nothing but it run the testers for the project. Say for example, project 1, there are for project 1, assume that there are A, B, C test cases, and the tester will test your project for test A. If it is running correct, then it will take us to the second test, that is test B. If it is running correct, it will take us to the next test, that is test C. So if the project has run for all the given test cases, all the automated test cases, then it will be the same feedback. Quality of your content or quality of the code will be given to your developer. Okay, and after that the packages the compiled code and resources into the artifact, like into a jar file or a var file. It will just artifact it, and then install it is nothing but installs the artifact in the local repository, deploy, copies the artifact to a remote repository. Okay, so these are the major life cycle involved in maven: validating, compiling, testing, packaging, install, and deploy. Everything is automated. We don't have to do anything here. You just have to write your code or build your code, and just you should put it into a build automation tool like maven. So it will take care of validation automatically, it will take care of compiling your project automatically, it will take care of testing the run cases automatically, packaging, and also deploying it into the remote repository. And that is the beauty of the build automation tool. And so here is the repository architecture we have. On your system, you will have one local repository. Like if you install Maven, you will get one local repository, and the same code will be copied to the central repository. I mean, to the internet. Central repository might be, you can go for using GitHub is also a repository on the internet. So we have so many central repository like JCenter, like that. So that is about repository. Whatever the changes you do on your local repository will be pulled to your central repository through the server. Okay, and here is the main architecture of maven. This is how it looks basically. So maven repository is a place where maven or dependencies of a jar file is going to store, so which are written in the file called as pom.xml. Pom.xml contains Java classes, resources, other dependencies. Actually, there are two types of repository, as I said earlier: a local repository and a remote repository. So maven reads the pom file, and it downloads the dependencies defined in the POM file into the local repository from the central repository, and it executes the life cycles, phases, goals, and plugins defined in POM XML. And why do we have to use Maven? It is, as I said earlier, build a project, easy to build project, and we can add jars and other dependencies of the project easily. Maven provides project information like document, unit test reports, everything. Yeah, that is one of the features of Maven. Like, it provides us the project documentation and also project reporting. Project documentation is nothing but the structure of the project will be given to us. Project reporting is nothing but after testing your code, the quality of the code will be given to us, and also like how many bugs are there in the file, if at all if exists. So those things will be given in the project report, and that is all automated. We don't have to create the project documentation externally, we don't have to create project reports externally. Everything is automated in maven. That's it. So these are the usages of maven. Okay, and let us come to gradle, another build automation tool which is known for its flexibility and also which automate the creation of the application. Both the automation tool basically used for Java based project. So probably you can even run C and also C++, but most probably used for Java based application. So you might be having this question, when we have Maven, why do we require a gradle? Which is because uh, the main reason is to this one, the last one. The Gradle resolves all the issues faced on the build tools like Maven, or we have Ant also. What is the major issues in the sense? So, as I said earlier, Maven completely dependent on POM file. So POM file is a file where we store the project details, project structure, dependencies, libraries, no? But that POM file is written in XML language. That XML language we should adhere to its rules and regulations very strictly. If you done any syntactical error, then you won't be able to execute your project well. And that is the major disadvantage of using Maven. That's why to resolve those issues, we have something called as Gradle. So it is very flexible, and here is this architecture of Gradle. And here in the architecture, you can see hello. The this is the image provided by the Gradle community, which represents the architecture and also the internal working. So let us understand the components inside this. So first part is the project. So here you can see the project. It is a software that can be built such as an application or a library. So we can have a single project or a multiple projects depending on the application. So each project have its own build gradle. You can see here each project have its own build gradle file along with the source code. So this is one project. It has build gradle along with the source code, and one more project with its own gradle along with the source code. So build gradle basically in the build file, actually what it does is the two types of dependency can be added here. So it provides the library plugins on which the Gradle and build script depend, and also the library on which the project sources depends. So that is what we call it as build Gradle. And here the next component is the Gradle. Is the wrapper is available as a Gradle and Gradle.bat. Here you can see the build flow, which standardizes a project with same version. Okay, and here we have the dependency manager as well. It declares and resolves the external resource required by the project. To add a dependency to the project, we specify the dependency in the dependency block that we will discuss as later. As of now, just know the architecture. And next we have I mean plugins or nothing but your what are the other necessary tools which we require to run the project, that is about plugins. And finally we can run our project for the I mean so many test cases, and then it will release the output, and the same output you can store it in the repository as well. So this is the architecture of the Gradle. And yeah, and after this, the one important topic that here in the lab is the key differences between Maven and Gradle. So there are so many key differences in that. The first one is configuration language. So when we talk about configuration language of Maven, so Maven's configuration language, it uses XML. We should strictly adhere to XML syntax. But Gradle, it uses Groovy or Kotlin based domain specific language we call for the configuration, which is more concise and readable because it is a domain specific language. And the next key differences is build process. In Maven, it has a fixed life cycle and phases. As I said earlier, it has validating, compiling, testing, install and deploy. It is fixed, we cannot change. and making it predictable but less flexible. And in gradle it offers more flexibility in terms of you can customize the tasks using gradle but not in maven. You can build your own logic, and it allows the developer to define the custom task and integrate with the different tools seamlessly. And next one we have is the dependency management. So dependency management here, Maven relies on central repository. Basically, you have seen the architecture, no? It is dependent on centrally for managing dependency through the POM file. But in Gradle, it uses central repository for dependencies, but can be more flexible in resolving dependencies and support multiple dependency repository. And when it comes to the performance of Maven, it is very slow, especially with a large product projects. It doesn't support incremental builds or caching natively. But in case of Gradle, performance is designed for speed and uses techniques like incremental builds, parallel execution, caching to improve performance. So that's why Gradle is very faster when compared to Maven. Plugin ecosystem. Maven is a large and also well-established plugin ecosystem with focus on simplicity and also standardization. But here in Gradle, it is robust and offers better integration with other tools. Say, for example, Androids with Kotlin and with the custom plugin development. And when it comes to community and adoption, so Maven has been around longer and is still widely used, particularly in enterprise environment and Java-based applications. But Gradle is gaining popularity, especially with modern Java virtual machine-based development like Android, so where it is official build tool. And multi-project builds here in Maven, it can handle multi-module projects through inheritance and aggregation into the POM file, but whereas Gradle handles multi-project builds more effectively with more flexibility and using its advanced task management system. So these are all the differences between Maven and Gradle. Now let us go to the so here is the installation procedure and setup of Maven and Gradle on Ubuntu. So for this, what you should do is you should update the we will be working on Ubuntu operating system. So the first step you should do is updation of your system package. So that can be done by using this line, that is sudo apt update. Apt is the advanced programming tool updation into the system. So after running this, next step is the installation of Maven. Maven can be installed by executing this command, that is sudo apt install Maven. And after the installation, you can verify it whether the Maven has installed properly or not by executing this command mvn-version. So if you are getting, if it is show after running the command, if you can be able to see the version, then Maven is installed properly. If not, what you should do is you should set the environmental variable. So just like you do it in your Windows operating system, no, there you will open the environment variable and you set. But here in this case, what you should do is, I have skipped that line. So after this, see, if you get any error saying that Maven is unrecognized, then you are supposed to execute this one, nano followed by this tilde / dot bash rc. You should execute this one, nano tilde symbol / dot bash rc should be executed. When you hit on enter button, you can see one window. So you should go to the end of that window, I mean to the file. It is a file, bash rc is a configuration file. Okay, so nano is to edit a file. So how do you configure something? How do you set environmental variable? You should go to the configuration file and you should edit it. Nano is a command to edit the file. It will open a configuration file and you should go to the end of the file, and there you are supposed to type export followed by, or else this is sufficient. This line is only this line is sufficient. Export path is equal to $path, and you should set, so your maven will be installed in ohm followed by bin, ohm maven bin. So that path you are supposed to copy and paste it here. Okay, and to save and exit out of this one, the configuration file, you should press control X, and meanwhile you should press control Y and enter button. To save and exit out of the configuration file, you should press control plus X, control plus Y, control plus Y, and then you should hit on enter button. That's it. First you should press control followed by X, control followed by Y, and release the control button and just click on the enter button. That's it. You will come out of the configuration file, and then you are supposed to reload the configuration file by executing source tilde /.bashrc. And after that your maven is ready. Once again you can check the version of the maven. So there you will be probably getting the proper version of the maven, and it is done and dusted. So next, installation of gradle is also same. Basically it requires Java to run. Your gradle, it requires Java to run. So first you should ensure the Java is installed or not. Otherwise you can install Java open JDK by executing this command, this one, sudo apt install open JDK 11 JDK, and after installation you can check the version of the Java by executing this. And to install the gradle we have this one, sudo apt install wget is a command line now. Command line argument where it downloads the external resource from the internet. Okay, we want, instead of unzipping a folder manually, so you can just download this unzip tool into the system. Okay, and that can be done by using wget. Wget is basically command line argument to download the external tools from the internet. So here I'm downloading unzip tool. Whenever you have whenever you have a zip folder, that will be automatically unzipped by using this one. So after this you are supposed to download gradle from this site. Here is the here is the address. After downloading it, you can, through the command, you can unzip it by executing this sudo unzip gradle, and unzip it and place it in this folder, which means that place it in a directory called as opt gradle. Unzip the gradle which is downloaded and then place it in a directory called as opt gradle. -d for directory, and what directory we are mentioning here, opt gradle. So when you run this command, it will create a directory called as opt gradle. There your gradle 7.4.1 will be installed, and after that the same procedure. You can check the version of the gradle. If the version is not coming out, if it is giving or if it is throwing an error saying that unrecognized, then you probably go to set the a path like this. Okay, how do you set? I explained in the previous slide. Nano tilde symbol /.bashrc, and go to the end of the file, and there you are supposed to set the path. After that, to come out of that, you should press control XY, and releasing the control button, press enter, and then after that you should reload the configuration by executing this. Then you can check the Gradle version, and that's all about the first program.